In this video, we're going to look at composition of functions. So this is another way to combine two functions aside from adding, subtracting, multiplying, and dividing them. And we're going to start with an illustration that will hopefully somewhat clearly explain what this really is and why we would want to do it. In this example, we're going to look at heart rate. Your training heart rate, if you're in training for something, is defined as your resting heart rate in beats per minute plus 60% of the difference between the maximum heart rate and the resting heart rate. It sounds complicated, but we'll break it down. So for example, if your resting heart rate is 70 beats per minute, then your training heart rate is a function of your maximum heart rate, right? It depends on your maximum heart rate, M. Okay, so your training heart rate, because it's a function of maximum heart rate, I'm writing T of M. So T depends on the variable M. So your training heart rate, it's your resting heart rate plus 60% of the difference. So your resting heart rate is 70. So it's 70 plus 60% of the difference between the maximum heart rate and the resting heart rate. So to do 60% of something, you would multiply 0.6 times, that means 60% of, the difference between the maximum heart rate and your resting heart rate. Well, that difference is, your maximum heart rate is M, which we don't know, so we're calling it M, minus your resting heart rate is 70. Okay, you can leave it like that, or we could go ahead and simplify a little bit by distributing out that 0.6 to get 70 plus 0.6M minus, if we do 70 times 0.6, let's see, let's try this again here. We're going to do 70 times 0.6. We really don't need a calculator for this, but that's okay. Is 42, and I knew that because 7 times 6 is 42. That's okay. So this is minus 42. Actually, let's put it down here. So we have 0.6M, and then 70 minus 42 is going to be positive 28. So that is your training heart rate as a function of your maximum heart rate. Okay? So, and that's assuming your resting heart rate is 70. But, okay, here's the composition, okay? The maximum heart rate is actually found by subtracting your age in years from 220. So your maximum heart rate actually depends on your age, okay? So if X represents your age in years, then your maximum heart rate is 220 minus X. So your training heart rate depends on your maximum heart rate, and your maximum heart rate depends on your age X. So therefore, okay, still assuming your resting heart rate is 70 beats per minute, if your age is in years is X, then your training heart rate can be written as a function of X. It would be this function up here, 0.6 times M, but M is 220 minus X. So I'm going to substitute in, let's do 220 minus X right there for that M. And then we have this plus 28. Okay, so this M corresponds to that, which corresponds to that. Okay, so this is your training heart rate written as a function of your age now. Okay, which we could also simplify. Although we don't really need to, actually, in this point. Okay, the point is that training heart rate depends on maximum heart rate, which depends on X. Okay, so the composition of functions is T and M. So if we put X into function M, okay, that outputs M of X. Then if we input M of X into the function T, that outputs T of M of X. It's a function inside of another function, where this M of X function is what I would call the inside function because it's inside this other function T. So this makes the training heart rate a function of age x. Age x, okay? Which, here it is pictured, training heart rate depends on maximum heart rate, which depends on x. So this is called a composition of two functions, when you have one function that depends on one thing inside of another function, because it depends on this one. Okay, so let's generalize now. More generally, if a function f depends on a function g, then the composition f composed of g has two notations. You can write f little circle, that means composed of g, parentheses x, or what that means is f of the function g of x. Now often in practice I like to use a bracket, especially if the functions are a little bit complicated, just to be very clear which parentheses go with which. Okay. So if we begin with the number x, you operate on that with g, right? You put x into the function g here, which gives us an output of g of x. Then you put that g of x into the function f, which gives us f of g. Okay, the domain is a little bit complicated, so I'm just going to mention it briefly. Basically, you can only use numbers for this composition function, for numbers x that are both in the domain of g and whose output is in the domain of f. Okay, in other words, if you end up dividing by 0 or something odd, right, that would not be in the domain. It's a little complex, so we're not going to get too much into that. Commutativity. Okay, what that means is that f composed of g with composition is not commutative. So f composed of g does not necessarily equal g composed of f. Okay, and we can find that and show that easily with a few examples. So let's do a more general example now with f of x equals x squared minus 7 and g of x equals 3 minus x. Let's find f composed of g of 1 and g composed of f of 2. Okay, we'll do this first one here in purple. So we're going to find f composed of g of 1. So that means we want to find f of g of 1. So first we need to find g of 1. You work from the inside out here. Okay, so we'll start on this inside part. G of 1. Okay, so I would plug 1 into g of x. 3 minus 1 is 2. Okay, that's the output from g, and now we're going to plug this 2 into f. So 2 squared minus 7, that's 4 minus 7, or negative 3. Okay, next let's find g composed of f of 2. You can go in either order here. Of 2. G composed of f of 2 means g of f of 2. So we would start now by finding f of 2. Well, we just found it. 2 squared minus 7 is negative 3. So I'm going to find g of negative 3 because f of 2 equals negative 3. So now we're going to plug negative 3 in for x over here. So we'll have 3 minus x, which is negative 3, which is 3 plus 3, or 6. Okay, that's how you compose functions f and g given input values 1 and 2, or you could obviously use any numbers here. Just to make sure this is really clear what we're doing, I'd like to do this example, which often trips up students a little bit, but really it's not too bad. We're just going to read the values off of the graph because we're not given function values here. We don't have f of x equals g of x equals. We don't have definitions like that. Instead, we're given graphs. G of x, it says right here, is the green, and f is the red, and I'm going to label that as well. Green is g of x, red is f of x. Okay. So we want to find, first, let's find g composed of f of 2. So that means g of f of 2, g composed of f of 2 means g of f of 2. So that means g of, okay, we need f of 2. Well, f of x is the red function, so f of 2 is what is y when x is 2. So we come over here, there's x is 2, we go up to the function. F of 2 is 3. Okay? So now I need to find g of 3, which I'm going to use the graph of g to do. So we go over to x is 3, go down to the y value there, it looks like -2. So g composed of f of 2 equals -2. You can also compose a function with itself. Let's find g composed of g of 1. That means g of 1, you work it the same way, we work from the inside out. So we're going to find g of 1 first. So we go to x is 1, and then up to the function g, which this time is up here. So g of 1 is 3. So then now we find g of 3, that's what we ended up finding over here. G of 3 is -2. Coincidentally, they're the same, but that's just coincidence. Okay. Let's find another few here. These are just a little bit more complex, slightly, given some equations. And in this one, the difference is we're not going to plug in any particular values of x. We're just going to find g composed of f of x, and f composed of g of x, and h composed of f of x. So we're given 3 functions, f of x, g of x, and h of x. And we'll find those 3 values. Let's start with purple here. We're going to find g composed of f of, we're going to keep it general, of x. We're not going to plug in a number. So that means g of f of x. Okay, so that means g of, well, f of x, let's see, f of x is right here, square root of x plus 3. So I'm going to write g of the square root of x plus 3, the whole function, okay, because we're not plugging in a particular value there. So now we're plugging this entire quantity in for x on this function g right here. So g is 2x plus 7, but I'm finding g of the square root of x plus 3. So this x gets replaced with root x plus 3. So I'll have 2 times the square root of, and I recommend putting parentheses if in doubt, square root of x plus 3 plus a 7. Okay, so you can see how this function replaced that x right there on g. Definitely pause this video and try the next 2 on your own. Next, we're going to find f composed of g of x. And I should have mentioned, this does not simplify any further in this case. Some of these may, we'll see. So f composed of g, that means f of the function g of x. So that means f of, let's see, g of x is defined as 2x plus 7. So that means f of 2x plus 7. Okay, so that's g of x. So I'm plugging 2x plus 7 in for x in my function f up here. So that little x right there will become 2x plus 7. So we'll have the square root of, instead of x, we have the whole function, 2x plus 7, and then we have this plus 3. Which in this case does simplify a little bit. These parentheses really don't serve any purpose here. So we can just eliminate those and then add the 7 and 3 to get the square root of 2x plus 10. And I suppose you could factor a 2 out, but there's really no reason to do that in this example. And the last one, h composed of f of x. Okay, this means h of the function f of x. Instead of writing that, I'm going to skip that on the step and just go straight to the function. It means h of the square root of x plus 3. So now we have to go to the function h. H is x squared minus 1. So this whole radical gets plugged in for that x right there. So we have the square root of x plus 3 all being squared and then a minus 1. And this one does simplify because when you square a radical, those are inverse operations. They undo each other. So we have x plus 3 minus 1 or x plus 2. That one simplified quite a bit. So that's it for this video on composition of functions.